last year I came up and talked about that Gulf of Mexico deep sea coral portal and the data that we're serving there. This year I'm going to talk about another coral portal we're working on. This is a digital atlas we made for the US Virgin Islands. The US Virgin Islands are one of the coral reef jurisdictions within the United States. They're just east of Puerto Rico, and the main islands are St. Thomas, St. John, and St. Croix, which are geographically separated. So the tool we made essentially was two tools, one for St. Thomas and St. John and another for St. Croix. The corals of the Virgin Islands used to be abundant and healthy, and now they're very much in decline. And so we're working with the Department of Natural Resources there to try and protect the corals through better land management and better designations of marine areas. The objective of our project was to provide the managers at the DPNR a tool that would enable them to visualize, characterize, and communicate the presence and value of coral, coastal, and marine resources while making management decisions such as permitting, restoration, mitigation, and conservation. To address this problem, we decided to create a portal or a digital atlas, an online tool with information available about the coral reefs in the US Virgin Islands. Into the tool, we put over 100 different kinds of information. The first kind was our benthic habitat maps. Our program, Marine Spatial Ecology Division, makes benthic habitat maps for all of the US coral reef jurisdictions. We do shallow and deep water habitat mapping, and we include these habitat maps as one of the key elements to understanding the distributions of corals and of coral ecosystems. We also looked at the distribution of hard bottoms, and not just the distribution of what we knew about hard bottom, but we also did a prediction of where we could expect to find hard bottoms in places that hadn't been surveyed. One of the weaknesses of the benthic habitat maps is that we can't go everywhere, and so we do some modeling to predict what we might find in places where we haven't surveyed. We also do some modeling to look at the habitats, especially to look at habitat complexity. We look at rugosity of the coral reef ecosystem, with the idea being that areas with greater habitat complexity can offer greater value for coral reef ecosystem conservation. We also conduct in-situ coral surveys and fish surveys. So we include the information about all the places where we know exactly what corals and fish are residing there. And then we look at the ecosystem context. We look at seagrasses, at mangroves, and we try to determine which coral reef has not just corals present, but also a full complex of ecosystem habitats, which includes mangroves and seagrasses. We also look at the fish diversity. We have fish surveys, and we also have predicted fish distributions. So we take advantage of the information we collect through in-situ surveys to predict what sorts of species assemblages we might find in areas we haven't surveyed. We also put in human uses or threats to the coral reef ecosystem, things like ship traffic and land runoff. This provides us with a terrestrial as well as a marine context for doing planning decisions. And we're very much interested in enabling a land-sea integration in coral reef decisions. Some of the permitting decisions being made by the management agency are terrestrial or coastal that will affect the marine ecosystem, whether others are directly within the marine ecosystem. And so we had the issue of both terrestrial and marine decision making. The functionality of the tool should be familiar to many of you. It's similar to what you would find in any ArcGIS online portal. We have the ability to add new information, or for a user to add new information from their own hard drive or from ArcGIS Online. Essentially, this allows you to create your own plans for the permitting process and then to use this tool to evaluate that plan. Here we're looking at the ability to customize the visual display, the information that you're using make an analysis. In this case, I'm looking at the Landscape Development Intensity Index on land. That blue polygon I'm looking at is the watershed directly adjacent to my planning polygon. And I can see there that compared to other watersheds, this is a fairly intact coastal ecosystem. I also see the presence of seagrass directly off the coast, and if I zoomed in closer, I'd see a high abundance of fish from the in-situ fish surveys. Finally, I'm able to draw within the tool to help create a conversation between the Department of Natural Resources and the permittee so that they can make proposals with a spatial recommendation and the department can analyze those things in a spatial way as opposed to just a written report. The tool also allows you to create and export a map automatically, which is very handy for permittees to be able to communicate what they're seeing and what they're proposing. So next I wanted to talk about a case study. One of the ways we've been applying this tool is to review applications for a floating restaurant off the island of St. John. We wanted to find out if the proposed site was appropriate for the restaurant, and we used this tool to try and evaluate that decision. I also put into this case study an extra proposal. We had the proposal for the restaurant in Hurricane Hole, and I wanted to use the tool to compare two sites. So I proposed on the top a new site in MAHO Bay, a place where I had a great vacation, and thought, wouldn't it be fabulous to put the restaurant right here? Then I thought, well, what can the tool tell me about this random decision I'm proposing? The first thing I look at is the benthic habitat maps. I want to know if there's coral reefs near the restaurant. The restaurant is using the coral reef ecosystem as a draw. It's a tourism element. And in that sense, we want to find a place that does have access to coral reef habitats, but not put the restaurant directly on the reef. Both of these sites feature that aspect. They have nearby reefs, but the site itself is not directly on the reef. Next, we wanted to look for endangered coral species and see what kind of information we had from the local coral cover. We found that both sites had endangered corals, and both sites had some coral cover remaining. None of the coral cover in the Virgin Islands could be described as high anymore, but in general, these were existing, surviving coral ecosystems. We also looked at the fish distributions. The fish are going to be a big draw for this, and so we wanted to find a place that would have high species richness in fish in particular. And we were also interested in the cohesive, complete ecosystem. So we wanted to find out about nearby seagrasses and mangroves, as that will also help sustain the health of the area. Using this analysis, both sites seemed to meet the criteria for a good place to put the restaurant. But I thought to myself, well, the tool seems to be informing the decision the way I had designed it, but I must be missing something. I picked my site randomly from Silver Spring, Maryland, without using much in the way of local knowledge. So when I took a step back from the tool and thought about what am I missing, I thought about the managed areas, the human uses. And in particular, I noted that the proposed Hurricane Hole restaurant sits just outside the national park, whereas my MAHO Bay proposal sits just inside the national park. Meaning that would be a big difference for permitting and probably less feasible in the park than out of the park. So in general, I felt that the tool was performing the way I wanted it to, but that making a decision just based on my spatial information wouldn't get me nearly as far as if I continued to work with the local department and make sure I incorporated local knowledge into each of my decisions.